MediaPipe is a cross-platform environment that you can use to be able to detect things like pose, hand detection of the digits, maybe the pointer finger, and also the face and other objects that you can track in 3 dimensions. We're going to go through an example where we couple MediaPipe with an OpenAI Gym simulator to see if we can control the cart. So I'm just going to run this and get the windows here, just show you a demonstration of this, and then we'll get more into the code and also do this with the temperature control lab as well. So it takes just a little bit to pop up. Okay, so there's my hand, and I'm going to control the cart to the left and to the right. And you can see I can potentially balance this if I am able to learn how to balance this pendulum. Okay, so that's the example that we're going to be going into, and it'll reset if you get outside of it, so no need to worry if you go outside the screen. Welcome back to the Machine Learning for Engineers course. In this exercise, we're going to be using hand gestures or hand tracking. So come down here to Applications for the hand tracking, and we're going to use MediaPipe's hands to balance a pole on a cart and also control an LED. So just go ahead and select this. This is MediaPipe. It's Google's offering for machine learning of especially face detection. You have holistic. This is a good example of some of the things with pose, hands, and face. And then it also has some of these other very nice applications. We're going to be working with this one from the hands, MediaPipe Hands. And you can see just a little bit about how it's able to pick out the different features of the hand. And in particular, we're going to be working with this index finger tip, number 8 right here. And we're going to be able to estimate where it is and then be able to control the cart pull from the OpenAI Gym. So let's just come down here. There's an online demo of this if you'd like. This one takes a little bit to load, but let me just see if I can make this load. You can try it out. This is the holistic one. It runs through your web browser, and again, it just takes a little bit to load up, but then you can see yourself and some of the face detection and the mesh and also your hands in this viewer. Okay, takes it'll eventually load, but it takes a little bit. So I'm just going to go back. You're welcome to try that one with the online demo. Okay, so first of all, MediaPipe hand detection. We're able to take photos of hands and be able to detect the sidedness of it, front, back, be able to detect the thumb. We're going to be working with this dot right up here, number 8, which is the index finger. And so they've labeled quite a few photos. I think it's 30,000 photos, and then trained neural networks on those to be able to detect hands, face, other body objects. And there's some code. When you're just starting off, one of the things that you'll have to realize about Python is that the strength of Python really comes from the packages that extend your capability with just a couple lines of code extra to be able to do some pretty amazing things. So we're just going to use the example that they provided. They have OpenCV, MediaPipe, and then we'll also grab this hand photo and then be able to detect some things about the hands. Okay, so just as you get started, you're going to need to pip install some of these. So just open up a command prompt, and then you can do pip install OpenCV Python, then MediaPipe and Piglet, I guess is what it's called. Okay, so pip install MediaPipe and also Piglet. Okay, all of those are satisfied, and then the other one is the OpenAI Gym. All right, so once those are all installed, then we can come down here to this cart pull example. So this pull is attached by a frictionless joint in a cart that moves along a track. cart is controlled by applying a force to the left, the action is equal to 0, or to the right, action is equal to 1. Now the pendulum starts upright, and a reward of +1 is provided for every time step that the pole remains upright. And the gym returns done, true, when the pole is more than 15 degrees from vertical or the cart is more than 2.4 units from the starting location. So that's when it says, well, you've been unsuccessful at balancing the pole. And this is a common one that's used in reinforcement learning as a gym, as a place where these algorithms can practice and receive this reward to train it. All right, so the basic code here is just to import the gym. We're going to make this cart pull V1, and we'll reset the environment. And then we'll go through 1,000 loops, and we'll just action space sample. That'll give us a 0 or a 1. We'll put a 0 or a 1 here in the action. And then if it's done, if it moves more than 15 degrees away, then it's going to reset it. Okay, it's going to issue the reset command, and then after it's done with those 1,000, it will close. Okay, so one of the things that you might need to do on this one is just create a new file. Okay, so you can either open up something like, let's see, I'll get Python, the IDLE. Okay, so that's one way to do this. You can click New File and then save it somewhere where you can run it. Okay, so there it is, the cart.py file. And if you can't see this, if you can't see that extension, just go to View, Options, and then Change Folder and Search Options. And when you go to View, unselect this one, Hide Extensions for Known File Types. Okay, and then click Apply, and then you'll be able to see the file extensions and change those. Okay, so let's just go ahead and close this and run this cart pull just to see what it does. So there you can see it's just giving it random actions, and then when it gets more than 15 degrees away, it just resets it from the start. And you can see it's just, this would be the training data that you'd want to give to some type of reinforcement learning. And it goes for 1,000 cycles and ends. But what we want to do is see if we can control this with our hand now. So it goes pretty fast. It's fairly difficult to control, but let's see if we can use our webcam to control it. So reinforcement learning, we'll use algorithms later on to improve the control, but let's first of all just see if we can do it ourselves. So I'm going to click this hand cart control. Now this combines the MediaPipe and also the cart control into one script. So if you click get this, get the code, you can edit this Python file and run it again. Okay, so now I'm going to run it, and let's see how well I can do here at controlling this. So it'll just take a little bit to open and load. All right, and let me go ahead and just move this over here. Okay, so I'm going to put my hand up, and you can see I can move it, the cart, back and forth. Okay, and let me see if I can balance this. Ooh, I got close there. Okay, so if I get outside this window, okay, I went too far over to the left, then it just resets. So I'm going to see if I can swing this up. First of all, what I want to do is maybe just try to get the cart in the middle. Okay, so first of all, just try to get the black box into the middle, and you can see it's just this index finger. It doesn't need to be the whole hand, it's just where the index finger is, that's where it's steering it. The force to the left or to the right. Okay, so I'm going to do it to the left, to the right, just try to get it into the middle. And then if you get better, maybe just try to stop the swing, or you can start trying to balance it. Okay, so you can move it back and forth with your hand gestures. All right, so that is the cart pull, and just go ahead and try it just as a demonstration, just to see how it's working with you. You can use either hand. It doesn't matter. It can be left hand or right hand. You can switch them. And if you do both of them, I'm not even sure. I guess it's going to go with the right hand. Okay, so maybe just use one hand instead of both of them. Okay, so that's the demonstration here. Now the challenge problem, I'm going to hit Control C here on that just to stop it. And the challenge here is now to adapt this hand cart control, where we were able to control this cart and pull system. Now we're going to try the same thing with the temperature control lab. And this is going to be adapting the hand tracking script to control the TCLab LED, or this little LED right here. So adjust the TCLab brightness up and down as the index finger moves up and down. We'll adjust the blinking rate as the index fingertip, the fingertip moves to the left and right. All right, so I'll leave that as an exercise for you. Here are a couple of the TCLab commands, and just go ahead and go through this. Put that in there instead of the cart pull. Put in the TCLab, and then you're able to control this LED. For this part of the exercise, let's just start with the hand cart control, and I'll do this in Jupyter Notebook now. Just grab the URL up here, copy that, and then let's just start a new Jupyter Notebook. Again, if you have different versions of Python installed, you're going to need to reinstall those packages. I already have them installed here. And in this case, I'll load, and then I'll put this in. If it gives you a problem with the HTTPS, just get rid of the S, and then run this, and it will load in the code. So let's just go ahead and try this just with the cart pull as a first test. Just make sure we have all of the packages. Okay, so let's see. No module name MediaPipe. If you're missing something, you can just insert a new cell below, and I'll just do pip install MediaPipe, and it will install it, and then just restart your kernel. So it's just going to take a little bit to download it. It'll collect it and install that. And it just says to restart it. So I'll restart the kernel, and I don't need to run this again. I might need to get some of the other packages. Let's see if there's any others. Okay, like OpenCV. All right, let me do this again. OpenCV-Python. And I think I need Pyglet as well. So I'll just get those packages. If you're missing any of them, again, just install them. Okay, so it looks like these are already installed. Comment that out, and I'll restart. Okay, and if it gives you this error again, sometimes what you need to do is pip install and then upgrade, because it needs to be on the latest version of the package. So I just wanted to show you some of these errors. And it says if you get an environment error, you might have to do it for your local user. Okay, so it looks like it's already up to date. I'm not sure why I'm getting that error there. Let's see if this resolves it. Okay, and restart the kernel, and no module named Gym. Okay, so I'm getting a little bit closer here. I'll just pip install Gym, the OpenAI Gym. Okay, so we'll install those. In this case, we're going to be using the TCLab. So you may also need to get the TCLab as well. All right, so I've got all my packages. I'll go ahead and restart. And then let me just try this one more time. And I'll comment that out for later. Okay, so there I have the pole and the cart, and I'm just going to move it to the right and to the left. Okay, so that works for the previous example that we had. Okay, so I'm going to stop this. Sometimes here it's a little bit trickier to stop. You see how it's not wanting to stop it. You can always come here and stop your kernel if you want to. This one right here, you can't just close it because it's just going to open up that window. All right, so what you need to do is interrupt the kernel, and then it will stop it. Okay, so that just froze the images, and then you can close them from there. Okay, so it's going to restart automatically. You can restart your kernel, and that's okay. We'll restart it, and then we can run it again. Okay, so we're not going to use Gym anymore. That was the one that we used previously. We're going to instead import TCLab. And let me make this just a little bit bigger so it's easier to see. And we'll get rid of these packages, the ones that were associated with the Gym. All right, and then we need to keep everything else here except the Gym variables, like the steps and the observations. So we don't need that, but what we are going to need to do is to go ahead and connect to the TCLab, and then we can do that at the very beginning. So for example, up here, I can have lab equals, and then I can do TCLab .TCLab like that. If you don't have a TCLab device, you can always do model there instead if you don't have one of the physical devices. Okay, so now I have lab and I'm connected to that, and then I want to create a new function. This one is going to be defining the blink for this lab, and I'm going to have the time period, and then I'll also have the brightness. All right, and then in this I'll have lab.led, and I'll put in the brightness, and then I'll have time.sleep, and I'll sleep for that certain period of time. Okay, and that's going to be my pause amount. All right, now one of the other things you'll see is we also need to import time to give us our sleep time. All right, and then finally we're going to set the LED to off. So it turns it on for that amount of time at that brightness, for the pause time, and the brightness bright. All right, and then we can return after that function. We can also just leave off the return statement here if we want to. Okay, so there's our blink function. Now based on the X and the Y, we didn't use the Y last time, but let's just come down here. We have the hand marks, okay, these hand landmarks, which are the X and Y. And I'll just initialize both of these. If we don't have a hand in the picture, I'll put X equals Y equals 0.5. Now it looks like it's complaining because I only have 2 spaces of indent here. It wants 4, but it can handle 2. Okay, so here I'm going to put in what we want the TCLab to do. So we want to call this function, this blink function, and we're going to call it with lab, and then we want to come up with the amount that we want it to pause. And we want it to pause, I'll say that's going to be equal to 1 minus x times 0.5. So x is going to be between 0 and 1. And if I go to the left, it's going to blink faster. If I go to the right, it's going to blink slower. And it might show opposite on the video. that's captured, but it'll mirror it to you on your screen. Okay, and then the brightness, I also want to do the same, 1 minus y, and I'll go up to a maximum of 50 on the brightness. All right, so I'm going to have lab, and then I'll put in my pause, and then I'll put in my brightness. Okay, so that's all I need to do to control the LED. Every cycle through, it's going to be looking at the X and Y position, the fractional position in that frame for my fingertip, and then it'll adjust the brightness and the blink time. Okay, so I'll run it. It's going to connect to the TCLab, and I'll bring that TCLab up just so we can see it, but it should come up with a window frame just to show the video here. And let's see if it's going to pop up. There it is. Okay, so I'll put my hand up now, and let me bring up the TCLab as well. Now the trick here is to get the LED in here without, okay, and it's blinking here, but I don't think you can see it in the video because the frame rate is too low. But you can see that I'm going to adjust the brightness up and down. There's a low brightness, and then as I increase it, you can see the brightness of the LED increase. Okay, now it stopped. Let's just see the okay, sleep length must be non-negative. So it looks like we need to, if we have it return some kind of a negative value, we need to protect against that. So let's just come back up into our code, and we'll limit. Okay, so let's see. I'm going to say that the pause and the brightness, I want to limit those. So I'll do the minimum of 0 or 1 and that. Okay, so it's going to clip it at a maximum of 1. And then I'll do the max of 0 and that number inside it. So I can also do that same thing here, but instead of 1, I'm going to have 50 for this one. Okay, and I think the maximum here that I wanted was 0.5. Okay, so that's how we can clip the numbers just so we don't get a negative sleep time, for example. All right, and looks like I have some kind of a parenthesis error. Okay, if you get this error right here, it means that you already have an open connection. So just do in a cell below, or you can restart your kernel. Just do lab close. And then it will reset the connection, and you can run the TCLab again. Okay, I'll run it one more time. All right, and let's see if this comes up. Takes a little bit to just initialize the web camera and start possibly loading some of the modules in there as well. I find it's just a little bit faster if you don't use Jupyter Notebook, if you just use a script, a text file. Okay, so it's going to get the window and then hopefully open up here in a little bit. I'm not sure what the holdup is. I think it's just thinking about it. This is a much longer delay than I've seen before, but let me just see if this is, oh, the window was up here, it just wasn't displaying. Okay, so I'm going to start this again. Here's the hand, the fingertip that it's identifying, and it's going to control the LED. I'll go up on brightness and then down on brightness. See if I can get that finger back in there. Okay, and if I go to the right versus the left, it's going to control the blink rate as well. So the frame rate isn't very good right here. It's hard to see that, but I am controlling the LED here. All right, so that concludes this one. I'm going to go ahead and just interrupt that kernel. Let me come back here and just review what we've done. We've taken MediaPipe and OpenAI Gym to be able to use MediaPipe and hand tracking to be able to control that pendulum, that inverted pendulum. And that's a great example that shows how we can control something on the computer. The LED was another example, but now we're going to control something in the physical world. And this gets into control systems and automation and how we augment a person's capability to be able to accomplish something. And the computer in this case is looking at hand gestures and be able to adjust an LED brightness. But you could think about a computer control system to be able to monitor what a person is gesturing and be able to make other types of changes, maybe in mining and minerals processing. A big dump truck that could be driven virtually by somebody motioning with their hands, or a scooper, or a plane that, you think about a child who tips his hands to the right and left as he's flying, pretending like he's flying, going around. You could potentially have a model airplane that also tips its wings as the child runs around playing like they are the airplane. So many things that you can do with that. I think it's kind of an exciting development to be able to couple this machine learned model of human gestures with controlling physical objects in the real world.